Welcome, I'm Bill Wake. We're here working on 10th, which is a programming language we're going to design, and we're starting to do our implementation in assembly language. And today we're going to work on the print function. I think we can get a print of an ASCII string going, a zero terminated string. Now, some housekeeping, slight. I had issues getting Atom to update and some other things. I dig around a little bit and find basically they've been in the process of shutting it down for almost, well, over a year at this point. And so we retired it. We'll try a new setup. This is TextMate. The thing I found with it is I don't think it has a good terminal approach. What you can do is you can put a command in your shell and then keystroke Command R run it, which I didn't see my keystroke. Here we go. I don't know if that's any better. I do think it's just this is the command we're going to run most of the time. So I left the terminal window up and we'll run it over here for the most part. I don't think the shell bit's helping anything. So I'm going to close that. Actually, I'm going to delete it. Okay. Yeah, too bad. Oh, well. I really would love a plugin that gave me a real terminal down here, but yeah, not there. Not available. I don't know if I can make this disappear. Yeah, mostly. Okay. Well, so what are we going to do today? A script to run make and out. Well, I think I'm going to use this. It's going to be what we do most of the time. So most of the time I'll do a change, come over, so it's a click and 2 keystrokes and a return for 3 keystrokes. I'll see. I don't know if there's a macro on this side. No. No, I'm not really seeing anything. I think you can also, is it bang bang? Yeah. Recalls the last command and runs it. But I think arrow and do it is going to be just as quick for the most part. All right. So yeah, well, I guess small piece that is, we'll call that. Well, I guess I'll restate it. 2024, last day of January, unbelievable. Print. Use this. Okay. Let's see. cLike print function. All right. Well, one thing is we have cLike, so we'll probably put it in here. But I do think our unit test demo is, it's got that in it, and I want to move it out. I basically want to make a cLikeTests folder. Okay, so let's see. I don't think new does it here. Oh, down here. Yeah, there we go. Okay, and we'll get pieces of unit demo. Well, we're not using that. Okay, we are using test start. These are the 2 tests that we're using. They do seem a little repetitive. I think we can improve them, but it's coming soon. All right, now we've got to add a new file to the makefile. Well, let's do cLikeTests.out. And I suppose we're going to have to do the same kind of thing. cLikeTests.int depends on, well, I don't, it certainly depends on asUnit.macros and cLike.s. No, I guess it's cLikeTests.s, and the linking is going to have to do it. $@ if this rule is helping. Okay. Move this one up. I think I can just say LD equals. And then I'll pull these. There. And let's try LD. Or is it $LD? I don't remember. Okay. Let's save. Let's touch unitTestDemo.out and make. Make sure. Okay. I guess I'll have to search on this one. Maybe it's $. This equals that. Okay, so fine. Oh, dollar parentheses. Oh, that's interesting. Okay, it was 18. Oh, sure enough. Line 19, missing separator. Well, I don't see what's wrong with that line. Tab, cat, $, arrow, right to $add, which looks exactly like that. I'll just take that line. Okay. Okay, that's fair. Okay. Grr. Okay. Yeah, we didn't put a start in. And I didn't save what I had, which probably doesn't help anything. We have to have that. Yeah, I think it works. You can override the environment or command line with those. All right. Let's see, our unit test demo. I've got a start method there. And I guess he will need exit. Okay. This gives us a place to put the test I'm going to forget to add to it. Okay. That goes there. Makefile needs to reference Unix functions macros. Assert equal. Well, yeah, my out. Oh, we're gonna have to. We're gonna do some more moving. All right, so we'll take these out. Test one, test two. Where's assert equal? Right. Failed message. I guess here message is old. Okay. I think we're gonna have to make a separate. Yeah, we need a separate package for that too. This is, well, I guess it's asUnit.s. I think I can keep these straight. And he's got assert equal, and we know to make it global. Okay. And all right. Now the makefile. Okay. I guess we're going to say asUnit.o depends on asUnit.s. And then the linking needs to pull in asUnit.o. This can be LD, $LD. It might be nice to put in a library at some point, but let's grow it up a little first. Okay, so now this thing has that. We also need that for demo out. Okay. Let's see if we got everything. Goal. Okay. LD, the first LD seems to have done okay. cLikeTests.out asUnit. Oh, I have that twice. Minus O cLikeTest.out. Okay, asUnit, cLike, and click tests. Undefined symbol start referenced from initial undefined. Assert equal referenced from cLikeTests.o. Well, it probably helps to save all these things. Let's try that again. No? Only slightly. Okay. That seems okay. Unit test demo, did I take it out? I probably should take it out. No, I don't think I have to. I don't think I have to do anything else to reference it. Global start. Need that in my cLike. Well, this can come out too. And there's our ad for our demo purposes. Okay. Is there a save all? Yes. Option Command S. Okay. Hey, there we go. All right. This is good. So we I guess I can do ACP. We pulled cLikeTests to its own file. Same for asUnit.s. Adjusted makefile. Okay. Back to to-do. Okay, so that's probably worth saying. We extracted cLikeTests.s and asUnit.s and adjusted make file. All right. So the cLike print function. Well, this is more. I'm not. I don't think I'm going to try and test it directly. We have it somewhere. Unit test demo. Okay, so he has the macro for print. Okay, we'll take that as a starting point. cLike, no, that's probably Unix-like. No, it's more cLike, isn't it? C has printf that this is trying to be. All right, so that's the macro. I want to make, well, I want to make a print function where you don't have to do the length. Okay, and I don't need it to be a macro. I think it can be an actual print. Print. It's going to be like the macro. Well, okay. So remove, we get standard out, x1. Well, x0 is coming in with the message. Unfortunately, the convention is you use the registers in order. So, yeah, all right. So let's move x0, well, x1 equals x0, which is your message in. So let's make this clear. Input x0 is address of a zero terminated string. Process, that's kind of TBD. Output. I think, I don't know what happens on the service level. I'll just say none. I don't think we really expect anything. I think I need a little more Putting on these. Okay. So we move x0 to x1. We move standard out into 1. Address of x2, x1. Well, that's kind of the caller's job. Let's call this print old. Okay. But x2, well, I'm going to have to do our little call sequence dance because I want to call string length. So you don't have to. Okay. Oh, yeah, we absolutely could use the C libraries. But I really would like to just do it at this level. I know it's pounding myself on the head in some ways, but yeah, I want to build this from the bottom up. I'm going to take the Unix level and accept that there's functions defined for this stuff, but beyond that, I want us to do it. We'll write a few extra functions that we could pull out of C, like string length, But yeah, it's part of this game, I guess. All right. Well, let's get my load. Okay, so print definitely has to do the save and has to do the restore. Okay, and yeah, you had to do a return. Okay, so we're pushing LR because, well, let's see. Let's do that first. We're gonna put well, x0 is the address, right? So we can just pass that along. And then x0 is the length. Okay, so we'll call branch length to string length. And then the result is x0 is the length. Well, we need that to be an x2. x2 we're going to have to save it. Okay. Let's move a caller saved, callee saved. In other words, we can set it here without anybody touching it. Okay. We'll call string length. We'll move x2 to x gets x0. Okay, so let me make my things. X20 is holds address while string length called. I don't really comment this much normally, so this is a little different. X0 becomes well, it's got to be standard out. Holds port number for standard out. X1 holds address of string to write. And then X2 holds length of string. And then X16 holds service number. Okay, so this goes. So we'll put 20 here. Well, no, I got to do this in order, don't I? X1, X0, no, X1 gets x20. Okay, so that's our temp. I guess we can move this down. Okay. Okay. Make sure we're doing this right. So x20 holds the address. We call string length, which does not mutilate the address in x20, but it takes that address and leaves the count in x0. Then we, oops, I do have to do this first. x2 gets x0. I think I can move this one up, so I'm doing it backwards. Whoops. I had a weird keystroke there. x1, x0, x16. Okay. Get the string length, move the length to x2, put the saved address in x1, write a 1 in standard out, call the right method. When you're done, return back. Okay. Yeah, right. Well, I wonder about that too. Let's see if this works. Well, how would we make it work? Well, who's calling cLike? Unit test demo does. Let's put it in there. Do we export that? Global string length. Global print. Okay. It's there. Then makefile. Test demo. Okay, first I'm going to hide print. Okay. Now, well, my start. Let's put well, let's put an asciz string in. So, hello. Well, I wonder if we can, I know you can make little macros. It might be worth experimenting with that. All right, so this is asciz. Hello. Okay. And we're going to load load x0 gets hello. And then we're going to branch to print or call print this exit. Okay. All right. So I think unit test demo should print hello if we're lucky. Yeah, there we go. Okay. Yeah, that's what I'm wondering. Let's see what we can do. I think it's EQU. Let's see. Do I have it listed in here? Assembly directives. Let's make these bigger. Equate. Yeah. So symbol equals expression. I'm going to try that. I don't know if it'll work. Let's do equals x20. No. Saved address x20. And then we'll try using saved address here. Okay. Let's see if that, do I have to put a $sign? Maybe it's not going to work. Let's see. You can do assembler EQU. Guess it's a numeric constant. Oh. Okay, so much for that. Okay, that's really too bad. Okay. Because 20. Right. Okay. I mean, well, in many setups, there is a way to call the preprocessor on its own and use that before we run the other stuff. I don't know. It might not. I don't know. My hope is that this is like a long method. We'll see. All right. X20 gets X0. How do we get... Okay, so we load this address into the register we call print. He pushes the link register. He saves X0. He calls string length. We kind of believe string length is good. X2 gets X0. That's the length. X1 gets X20. X0 gets #1. What's that? Oh, at. I don't know why this at slash thing is in here. Oh, there it is. Okay. Did we... I don't know. Invalid operand for instructions. Oh, that's this error. Okay. Sorry, let's get back to our crash. unitTestDemo.out. Okay. Now, print 2. Do these guys call print? He calls print. None of these are calling print. Okay, so I don't think this macro's doing anything for us. Okay. Load XR, hello. Print. Can we... Another one to look at is M4. I don't know if they have it on here, but it's the old macro processor. I don't know when. Oh, they do. I mean, we could go down this route, and you have show expansion, which is handy, but I don't remember anything about how to use it. I just remember it exists. I know I used it for something way back when. Define, include. Maybe this is worth it. We'll see. First, we'll get print working, and then I think print working will unlock some of the other stuff we're doing. Okay. How can we... All right. I guess the thing to do is I'm going to move exit up. Okay. I'm going to copy it here. And then if it dies here, then the load was fine, which I expect to be fine, but we'll make sure. Okay. And then presumably the print is the troublemaker because the other stuff was working. Yep. Okay. This is like the stupidest debugging ever. I really wish we could get a breakpoint in there. All right, this, and then our cLike. Well, let's make sure we pass the string length. Okay. Of course you are. Makefile. cLikeTests. Oh, cLike doesn't. Well, I can combine this, can't I? Well, that's fine, that's fine. Makefile 18. Cat, dollar, arrow, greater, cLike.int. Did I? Well, 18. Cat, dollar, arrow, greater to, cLike.int. That seems okay. Missing separator. Oh, it converted it. Huh. Okay. Is it converting it to spaces on save or something? Oh, geez, sure looks like it. Oh, golly. I didn't see an option for this. Soft tabs. Use tabs. No, is it going to convert it for me? No. He converted those. Okay, maybe I never changed today in this new editor. Okay. So we have our segmentation fault. After string length. Is that right? No. So we exited after string length. So string length is blowing up. What does that mean? He's not calling anybody, so he doesn't need a prologue. Let's make sure the address we're doing. I'm pretty sure I made that right. We got asciz hello. And he's in range of this. Okay, so I'm assuming he gets this address. Well, let's read up on LDR just to make sure I'm not making up how it works. But I think he's supposed to be load relative, and he's right next to something local. The somewhat allocated data word. Okay. Yeah, so I think this is one of those instructions that gets treated funny. Oh, we could disassemble. If using immediate, it does fit in a move. The assembler turns it into a move. Well, maybe we need to do this. Load the binary into LDV and add breakpoints. Okay, well, we should. Let's see. So this, I think, as long as you do it at the beginning and end, you're okay. And if you're a leaf, like string length doesn't call anybody, so he doesn't have to push. He basically doesn't touch that LR register, so there's no point in him pushing and popping it because he wouldn't change it. But maybe the load without the equals was doing some weird confusing thing, and this should say, oh, I'm 12 instructions away, I can reach that, let me use it. I hope. All right, I'm going to move the instruction up one. My hope is it just quits before we get there. No. Well, wait a minute. Huh. Okay. Oh, it is string length. Oh, but I know something else I didn't do. Sorry. Unit test. Got to close that for a minute. Close that. Unit tests. I put this in. I need to do in a line again. I don't think that should cause the problem, but all right. Didn't. Okay, I'm exiting before that. That's fine. Exiting after it. Ceased fault. Okay. So something here. All right. I think, yeah, maybe so. Yeah, I should double check that. Make sure I'm not messing up this. Yeah, call these saved. May use if saved and restored. I mean, no one's using it, so well, is that possibly necessarily true? Okay, let's. Oh, I got to use one of mine. X9 through 15. Let's do that. Let's do X10. 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 Okay, well, apparently that's not the immediate issue. So, maybe let's put a print old. X1 screws everything up. That's why we want the function. Okay. But it is good that we switched to X10 because yeah, we can only use X20 if we save it. We didn't save it. We don't use it, but maybe there's some startup thing that does, and we blasted it. Which maybe this is just sort of multiple problems in that case, but this should be safe. Okay, we put the string coming in into a temp. Call string length. Okay. Now maybe X0 gets one old message. And length. Oh, that's the message we're printing. So yeah, I should be able to call that. It'll screw up everything else, but okay, I'm here with length of 4. Okay, so I should get a here. I do. Okay. Now, string length. Unfortunately, if I call this stuff, it screws up all those things. What could be the segmentation fault? Okay, let's see if well, I don't know. I got OD minus C. That's not going to be good for a disassembler. Mac disassembler. Hopper. Looks like I got to install something. O tool minus VT. I don't know what O tool, how it's going to find anything. Okay. Excuse me. Okay, specify a file. Okay. cLike.out. cLikeTest.out. Okay. Not sure that gives us much, but okay. Assert equal. Compare branch equal return. Failed message. So it is getting the symbols and linking things together. Okay, this is nice. I mean, there probably are fancier ones, but okay, your start. Store X30. That's the link register. Okay. Branch empty string length. That's our two calls. Oh, I want to dump unit tests. Okay. This is all text section, so that's the code section. I'm not sure what the underscore text does. You may be able to make your own name for that. There's assert equal. X0 gets X1, X0 gets 0, X1 gets X0. Load RB, X2 with an offset 1, compare to 0, branch equal to 3EB0. Well, 3EB0 is return. Otherwise branch to 9C, which is this. Okay, I mean, this is, well, even if it didn't, right, it would eventually hit a 0, I think. But no, we did make sure it was ASCII Z here. Oh, we're curious about the start, right? So here's start. Store, yeah, 30 OX9C. Huh. OX9C. Oh, that's probably how far away it is. There's a calculator somewhere. There's a calculator. Put him on the next page. How do you switch modes? Programmer. Okay, so if I take 3F04 plus a 9C. 3F04 plus 9C equals 3FA0. 3F 18, 20. Where are you going? F0, UDF 00. What's a UDF? Undefined. I thought they specifically did not. Oh. the operating system does what it wants with them. Well, that's not very promising. And I think it's a 0, in fact. Maybe not. So what's he doing then? He's taking x0. Yeah, I really thought that was going to be like 2, 4. So load R. Okay, let's make sure we understand this thing. I think that's where it was before. LDR loads a half bit. LDR is a pseudo instruction. Well, that's the number stuff. Armor pound sign marks the immediate values in R0 registered. Oh, LDR without equals does PC relative loads. Maybe that's the problem. I thought I was being helpful. Okay. Do a save. Okay, and then now the V tool. Okay, we're start. LDR OX24. That's what I was expecting. It's still faulting, mind you. 24, is that right? 3FOC plus 24 C D E F 0 30 3FOC plus 24 3FOC plus 24 3F30. Okay, well, that's good then. I guess it moved down a little. Okay, I think this is just like making up instructions because it doesn't expect me to put data in a code section. But I think the hello points to ASCII Z. That seems legit. Okay. Now that X0 should be the address of hello. I mean, that's kind of the test we did, I thought, on string length. Okay, push that. Branch past the word. Okay. Yeah, we could do better on those too, but all right. Let me capture this first. It's kind of stuff we learned today. I learned Okay. And then okay, those two seem helpful to remember. Okay. And we're still crashing. Let's make sure I think I saved everything. All right, so where's start? We load, presumably this address 3F30, because it should take the PC plus the offset and get here, which seems like what it's doing. Branch to print, branch to test, and then some stuff happens. Okay, exit stuff. All right, well, that's one helpful thing. The next helpful thing is load the binary and add breakpoints. Okay, OX6F and OX21. Oh. I had thought it was Little Indian, but I could be wrong. OX6F. Where are you getting those from? Oh, I see what you're saying. 6F. Huh. Yeah, that does suggest, doesn't it? And UDF. Interesting. Yeah, I was the instruction for hello. Well, HELL is 4 bytes. What is that? Should be HELL O bang 0. Well, that's the O bang, and that's the HELL. Who knew? That was L. All right. Okay. So at least looking at this, I believe we're going to get X0 containing this address, 3F30, because it's PC relative. And that should take us pointing to hello. Okay, so I think that part is legit. Let's find string length. Okay. X1, X0, X0. This is backwards, so it always gets me. X1 equals X0, X0 equals #0. Load W2 off the address in X1 with the character number in what is that one? I think we still have it here. Load character and increment pointer. Oh, we're incrementing X1. So the address is changing. Okay, and then we also increment X0 so we get the count. And then branch back to 3EC8. Yeah, that seems good. Okay. All right, let's figure out this debugger situation. So I can say LLDB unitTestDemo.out. There should be a probably B or something like that. Set a breakpoint using one of several formats. Okay. Oh, they're actually going to document something. Okay. Break, foo. And I can say file line. Okay, maybe it keeps them. Let's try it. But let's break on string length. Now I don't know why 2 locations. And let me make sure that okay, I took out the exit here. I don't have it here. Okay. Well, I guess we just run. Allow. Okay. See, now we kind of were here before. And load our Q0, add R. That does not look like our code for string length. We should be seeing a move. Load R Q2. We're doing a load RB. Q2 is that the floating point? Huh. All right. I'm going to continue. Is that C or? Yeah. Right. Yeah, this is kind of where I got balled up yesterday. Libsystem platform dynamic lib. And I don't think I'm changing. I don't know if that's where we are. Lib dial. Now I think there's a way to show your breakpoints. Commands. Excuse me. I don't know. That's why I wonder if that was the second one. But like why they'd be calling string length in the dynamic library for starting up, you think that'd be not so necessary. And why are they calling it a dozen or 20 times here? R break. Registers would be useful. I don't think V is going to get us anything. Yeah. Set minus name. So that's fine. I mean, we can try one of those. Breakpoint list. Maybe I can kill one of them. 2 resolved. One is... Yeah, we don't want 1.2. Okay. How do I remove breakpoint? Remove. Delete. Delete. Breakpoint delete. No breakpoints. Deleted. One disabled. Okay. Continue. That looks more like us. Yeah, so I think it's got that dynamic library, has its own string length. Maybe it's like putting up a name in a listing, processor status or something. All right, so we are here. Okay, and we should be able to, I said, R for the registers? No. Register read. I don't know which registers. Okay. Oh, okay. There's our LR. unitTestDemo.out string length plus 44. X0 is that. Now, can I get the memory? I wonder if I can get it to read it as a string. Yeah, maybe not. Oh, format X. Wow. Okay. Format. Specify a format, you guys. Okay. I don't think he's going to give me more help. Memory read format. No. Okay. So you just put the statement with minus F. Oh. Okay. Memory read minus S8 minus F minus count. No, let's do 16. And then the address. So far back here. X10 contains the string hello, not the address. X10 contains? Oh, how weird. Okay. This should have the address. Yes. Okay. Ah. 216F6, C6, but is it using the, okay. X10 contains the string hello. Is that the same number? X10, C6, C5, yeah. Well, what could be? It's like, so I guess we're saying this X0 is not the address of hello. Um, How weird. All right, so unit test demo. So that's loading as the constant. All right, let's see what this thing's doing. Inster at page. And they're doing this. Where's Inster? Well, let's load it like they do then. Page off. Inster at page. What is Inster at page? Oh, it's the physical page. Okay, let's try this. Okay. That's what we passed to print. All right, let's let me so weird we got that. All right. Let's add to this. See what all commands I've done here. It's too helpful. Okay. That was last time. Okay, we break on string length. Run, continue. No. Set minus n. Run, continue, breakpoints. That's breakpoint list. Register read. That's a little small. Okay. Oh, well, I it loaded the byte from the address into the registry. Was it LDR that was used? I um yeah, the code used LDRB. Let's make sure of that. Okay, so so that uses that. And it's loading it into a 32-bit register, but it only gets a byte, and it zero fills it, I think. Okay, so now quit. Yes. All right, let's see. So we think we've got a more accurate load that hopefully gets the address with all the grief that you have to do to get that. Okay. Well, save all. Okay, we got that extra character on the end. I don't know what that's about. We had it before. No, I think oh, I see. LDR, I think because we were using the registers 64-bit registers, using those, it should be okay. What is that percent reversed thing? But that's a good thing, right? Because that's is it writing the zero? Let's make sure. String length is in x2. That's length. We were getting it before. Let's make sure this count is doing its thing. Okay, so if I have a one-letter string followed by a zero, well, no, let's take the zero first. So I have the address, I have the count zero. I load W2 from the address, increment the address. Compare W2 to zero. If it's zero, return, and zero is all we had. If it's not zero, this character was A. We add one to the counter, go back to the top. Now this is two position, or well, it's position address plus one. Load the byte, add one. Let's make sure this is post increment, but I'm pretty sure that's what we decided that was. Yeah, it adds after. Well, okay, yeah, let's do that. I mean, let's see. If this is one and the value is zero, then the count doesn't get bumped again. I don't know. It's test demo. Hello. What the heck? Okay. Maybe it just has to be new line terminated. Well, that's Yeah. Why would it write? Why does it go away? So I think if I take this new line off, we'll see it. Oh, okay. That seems to be what they're requiring. I don't know if this percent is this one inverted, like my real one, or if it just happens to be an inverted percent. Okay, but that seems like that's like a thing that would affect anybody. Oh, okay. Well, printf just calls write, the Unix level write, and apparently that's just the requirement. I guess I'm wondering if we did it twice. Let's try that. I'm going to put the whole thing twice just to not worry about it. Okay, save that. I got hello percent. Is that what we're going to see? Yeah, so okay. I think I don't know what happens if I do a C program that does that. Maybe I should try that sometime. Okay, well, I think we're time for a break, and I think we deserve a break. We just got something printing from a string we didn't have to count. So, woohoo. All right. See you in a few minutes. Okay. Oh, good. Thanks. Yeah. I don't really care what it shows. We'll just know we have to put a new line in somewhere at the end of a text, just like any other program would. All right. Sorry. Let's make sure this is good. All right. Hello. We did it twice. Okay. So we learned how to load an address properly. Maybe a tab would be better. All right. Let's save this, run that again, and make print take a C style string. Good. Okay. Now let's well, see that function takes an asciz string. I think we have done that. All right. So what I want to do, okay, we don't need this anymore because we have ours. Okay. And then the test demo, I think we should be doing more like this in our macro, wherever that is. asUnit macros. Align. Right, I'm going to pull this to the end. Oh, no, can't. Okay. So we're okay. Get my head straight on this. So this is macro test start. We align. We say we're in the text. I don't think we need to say this because we're not getting out of it for now. Okay, so we get this and we skip around the string name and we go to an exit with a no op. I don't think we really need the no op. Add a new line in the macro. I don't think we want to, because you might print part, and then print your new line. I don't. I think I'm going to leave it up to you, the user, to print that last new line. I think we know what it is now, so if we see it, we'll know why. Okay. All right. I guess I was wondering about. Okay, I think that's okay. This thing. Yeah, the tests. Okay. Where are the. I guess it's the Unix. No, the cLikeTests. Yeah, we don't have to do this way. Let's move this down. Okay. We'll mention empty string. We don't need the branch. And the test end is going to do return. So this is just here to let us do the test. Okay, so point to empty string. Now this is making me wonder if we're really doing what we thought we were doing. Branch here. Jump to call stringling. X1 is 0. Assert. Oh, we've got the test name. And assert equal. Okay, yeah. Same deal here. We don't need the branch. We'll keep the label. We'll keep the align. Don't need the label. Okay. Make sure these are good. Rearrange string tests, so constant comes after method. No need to jump over it. Okay, kind of a long message, but all right. Yeah, so I think what we want to do, well, the reason I started down this path is I want assert. I want to print the message if it fails or if it succeeds. Okay, so I want let's see. So I think the macro can he call a print? I guess that's my question. Gosh, it makes me think that we need that more complicated load. I'm kind of like not sure what to think. Let's put a print in here. Align to the test start. Test start. after the string. Yeah, you have to, because we're putting the string in the code section, the text, well, literally .text. And this could be it could be even or odd or whatever, so it doesn't have to align to the right number of bytes. So yeah, I think it's what we want there. Okay. What I want to do though is I want to call our print here BL print, and Unix exit. Okay. Are we running this? Have I screwed up? Okay. We're going to do the make. I want to do cLikeTests.out. Yeah. Are we not running? Did I not say /? Okay. Now, no, I think a line after ASCII is really needed. Because, right, it could be 0 letters or 1 letter, or, I guess you get 8 characters. It could be 8 or 9. If it's 8, it only takes 1. Well, is that going to work? I'm not as sure now. The statements have to be on a two line boundary. That's what it is. Or they have to come 64 bits at a time, I think. And if we had a short string, it would only be 130. No, is that right? Yeah, it would, let's say this is one instruction, well, 132-bit instruction. The next instruction has to be on a 64-bit boundary, and this kind of guarantees that it won't. I think it's okay. In the test file, okay. cLikeTests, just start. Well, yeah, I think. I see what you're saying. That if we put it in the macro, we wouldn't have to add it before the next test start. True. Yeah. We're putting it up there to make sure. I guess, yeah, that's probably something we could omit. But it sort of says whoever comes after you has to do it, so. All right, let's see. cLikeOut. cLikeTests. And cLike. Okay, let's get those over together. cLikeTests, we print that and exit. All right, and then let's do the same thing here. Okay. So I don't get it, honestly. We used ADR here, and it's just fine. Why would that matter? I mean, I'm pretty sure the range you have is like 12 bits. So is that 4096? That's less than I thought. I thought it was like a megabyte or 4 megabytes or something range, which is 24 bits, right? So this is printing hello world with an ADR, but in our test demo here, we could not use ADR. Like, what's the difference? Okay, now well, let me try it this way. ADR X0 hello. I don't know if this page thing, maybe there's something else. I'm going to comment these two. Well, now we have print working, so we can judge this better, I think. Okay. That's just the hello. Unit test demo. Oh, is LDR? Oh, okay. You're right. All right. Well, I guess this will be the way you get around it if you need to do a long load, because we will in some circumstances. I think actually this is probably worth sticking in here. Add a slide. This is like a long load, because if we put stuff in the data section, right? So the linker takes everybody's files with all these text and data sections. It consolidates the text to the bottom, then the data, then the BSS, which is the block reservation stuff. Then it puts the heap, and then the stack coming from the top. Okay, well, this is good. And I'm going to make a style change. How do I replace tab? No. Find space, replace with tab. Okay. All right. I think I'll use those tabs consistently. Yeah. All right. So, okay. Okay. Then let's do another ACP. Well, I mixed things. I reformatted, change load to ADR for a short distance load. And I think that's it. Yeah, probably a little more. Okay. Now what I'd like to do is we're doing a manual print for this, I would like to, if it succeeds, I want to print succeeds. Okay, so I want to say ADR success, well, pass message. X0 pass message, right to print. Okay. Now that means I have to do my load record, load this. Okay, so assert equals getting a little bigger. And then my restore. I probably should practice typing that. Okay, so here, and we have 2 exits, so unstructured VR. All right. Okay. Replace 2 with 1 tab. Oops, that's what I want. Okay. Pass message is asciz pass. Okay, that's that print. Well, this will be progress. Let's see, like pass. Run unit test. Pass. Okay. And I think this might be good with the new line. All right. So now if you succeed, we print pass. If you fail, we print failed, but we're going to make it the new way to print. We'll do ADR X0 failed message print, and that all goes. Right. Now I think we can make that better, but let's see if we're working. Press pass or fail message X0 equals X1, fail message if not. Okay. Okay. All right. So I think we'll get passes. And then I want to modify this. Okay, I want test start to print. So he's enter X0 gets LTS underscore back test name. And I think in here I can do this. Okay, and here's an example. We're not composing the whole thing. be any. Oh, yeah, I think I probably should just set the message to one thing or the other, and then fall through one short thing would be a better implementation. But okay, so we're printing the test name and the pass status, I think. I hope. And this is manual testing. Hello, pass. Oh, you got to call print. Skip over that. Okay. I think we're cooking. Okay. And now it'd be lovely if I could put the file name in, but that was unit test, click test. I think we're doing good. All right. It's kind of primitive, but this is good. Print test name and pass fail for assert equal. All right, now let's see. So failed. I think I'm just going to load the message. And branch to exiting. And I should be using my locals. I don't know if I need them on these. Can you add the escape sequence to right past? Yeah, that'd be nice. Think that'll work? Okay. Push, compare. If they're different, go to failed and save x0 failed. Otherwise, set x0 to passed. Skip that, print, and return. Okay. All right, let's touch see like test.s. Okay. Wait a minute. Shouldn't that say pass? I've still got test code in there, I think. Grr. cLikeTests. Nose length for non-empty string. Yes, I do. Oh, and that blasts out of the whole thing, the exit. Okay, nose length for non-empty string. We load. Hello? That does that. Okay. I guess our test stuff is paying off if I... Oh, no. Did I change the length? I put the new line in. 5, 10, 11, 12. GLLO space WORLD space bang. That is 13. Hello is 5. World is 5. space, bang, exclamation is 3. Okay. All right. Saved us from a situation. Okay. So ACP, we've I guess we fixed bug in length test, and I don't know what I've changed. I guess we restructured assert equal a little bit. Okay. Yeah, so let's figure out those escape sequences. Oh, I looked for M4 in the break. Let's see, terminal escape sequence to write in color. Okay, 033 bracket something. Where's color? Foreground color. Okay, let's see. So slash 033 bracket and then something M. Okay. asUnit pass slash 033 slash 033 test start, create a label and store the test name. Yes. That's we're getting the test name here. It's being used. The test start creates that label and prints it. Yeah, it does. We could probably put a bullet point or something in front of it. Maybe might look nice. All right, let's see. And C use blank. Okay, and then I got to do XXXM. The first part makes the text 31.1. Bold, red, 31M. Well, that's red. 31. Green is 32. M, and then black's 330M. I guess I should just say fail. There we go. And let's see, like, where's the others? Okay. I guess I got to make a test fail just to make it interesting here. Where's cLikeTests? Okay. Let's put this back to 12. Ah. Oh, I didn't change it either. And it put an extra bracket in. red is 31. Yeah. Yeah, but I think like a little bullet point might be kind of nice. I guess that's back in the macro. Or a little minus sign maybe. Or a star. Yeah. Okay. Miss any saves. All right. ACP. Put pass or fail in color. Oh. Whoops. Let's take that failing test out. Okay. Yeah, there we go. All right, nice touch. Yeah, thank you. Okay. Let's see how are we doing on time. 4:12. All right. To do. Yeah, we've done that. It's really to print test name and pass or fail. Okay. Put all the source folders. I think I'm okay for now. All right. Oh yeah, no worries. Yeah, it's kind of, I mean, we're kind of spread out, right? You got to look at the macros and the code and all that. But yeah, I did put a print in here with the asterisk and we're good. Okay. So, the next thing I want to start, let me go back to day 1 here. Oh, there it is. So I want to start the interpreter stuff. We've got enough of a JUnit or XUnit to get started. I think we'll get a little bit done. At some point, we're going to want to say like, gee, it's nice to know it failed, but I'd like to know what X0 and X1 were that you compared and thought weren't equal. But we can't print numbers yet. So I think we'll hold off. But this is what I want to target, this notion of a primary. Well, I guess for assembler, we could have used ASS, but I just stuck with AS. All right. But anyway, the primary, so the way it's created is you've got the machine code and then you've got some header stuff beforehand. And I think we're going to take our baseline code and link it kind of semi-manually, link them together, and then I think we'll be able to make them, put them in a dictionary like that. But first thing what I want to do is just stick a piece of machine code, some little assembly handwritten routine, and stick header information in front of it and verify that looks right and that it runs right. So somewhere on my desk, tomorrow's blog that I haven't finished yet. I had a version of this. I mean, what I remember is the header is basically it's the name. They used to use the length, but I think I'm going to say the name is enough. And maybe for now we'll restrict it. Yeah, the length of the name and the first 3 characters. I think I'm just going to make it the name 0 terminated, so you get 7 characters. Now, some of the words you might want to be longer. We can play with this once we get it working, but I think that'll get us going. I mean, they're relatively expensive. In the old microcomputer days, right? You had two 2 byte addresses, 64K memory. And, now we pay 8 bytes per word. And they could do, single byte stuff much easier than we can, or at least a little easier. Okay. So, I know we had I guess I didn't make a picture of that. That's so unfortunate. They had the header, had the length, the name, and then a link to the previous address, to the previous dictionary entry, and a link, and then the address of the starting point for the code you want. So in the secondary, there's a little interpreter routine that knows how to walk through this list, and you put all the secondaries get the same header, get the same routine name here. For this one, we can just point to the code right after us. Yeah. Okay, so let's again. I know I took these notes. Yes. Okay. Get my project separated here. I don't know if you'll be able to read it or not. Okay, let me read it looking at it here. And I'm probably reversed because I do my music. I want to be able, people can see my hands the right way. All right. But yeah, we can just lay one out briefly and go from there. So I'm going to make I'm going to call this core, being the core of our new language, the 10th language. Okay. And let's make, well, it's going to start kind of like this, this with some globals. Okay. All right. And so the name, okay. And we may make some macros for these, but the idea is, I'll call this entry. No. Maybe I'll call it primary. A primary. All right. We're going to have a string. And let's see, what's the easiest thing we can check? I've got, okay, let's make a primary for new line. New line. That will print new line. So I got to make this thing 7 letters. 1, 2, 3, 4, 5, 6, 7. I'll just put some dots. 1, 2, 3, 4, 5, 6, 7, 8. Or maybe I do dot. That's sometimes, or even 1, 2, 3, 4, 5, 6, 7, 8. Okay. That gives me one word. And then I think I'm going to make an unused word, quad 0. Okay, so quad gets us a full-sized 8-byte entry. Okay. So this is, oh, that's 8 letters. Okay, then I guess I don't need this. This is the name. 8 bytes. And then the header. These notes are terrible. I'm glad you couldn't read them. Okay, I guess it's the link. In this case, it's 0. Link to a previous entry. And then that's the minimum header. And then I don't know how you do this. I want to say, can I do this? Quad dot plus 8 dot plus 2 1. I guess it's bytes 8. So dot should be the assembler's, like, what's your current position? I don't know. We'll see. All right. But anyway, this is, let's see, what would you call this? This is the pointer to code. Now, this will tell us, or we don't care. We don't have to classify it as being primary or secondary, because the secondaries just all use the same routine to get there. And now we can have the code. And then at the end, we're going to have some sort of return. Well, let's just do ret for now. Okay. And this word, well, I think in case we want to call it, we'll call this new line. So we're going to say, we're going to do that load return stuff. The LR stuff. Oops. Well, as you were, oh well. And then, oh, I opened a new one. I don't know what I did. Put this over here, put it back in a moment. Well, okay. Yeah, it looks better. I told it was MIPS assembler, so we get a little colorizing. Ugh. All right. And then the loader. Okay. And then the code, well, it's going to be ADR X0 gets new line character. And then print. And then L new line character. Is asciz new line. All right. So I think this might work. I guess we could just call it, right? Yeah, let's do that. Well, it's a good test. I guess unit test demo's doing all kinds of stuff, so let's do that. he's going to call new line. We'll have to make that an entry point. Global new line. There's no start. He's just a little thing. All right. So the name of the method, a link, which is 0 because this is the first. I don't know how it's going to work overall. I don't know if I could put the new line name in here and get the right thing or not. I don't even know if this will work. So we'll see. Okay. And then this is just calling new line. All right. Whoops. Save those. Makefile needs to know about core. As. Well, I think I can just say core.o depends on core.s. Okay. And then unit test demo should get a copy of core.o. And we want to run this unit test demo one. Okay. Here no 2, path equals core, LD. LD? File cannot be opened. Core.s, I do not have a core.o. Why did that not work? Okay, we'll get that stuff. Load Mac OS, unit test demo, asUnit.o, cLikeTests.s. He assembled this one. Oh, that's got the intermediate. asUnit though. .o. Let's touch. Core.o. Okay, well, I'm going to put this in. Illegal hardware instruction. Pointer not aligned. Missing the primary field after the code pointer. Missing the primary field. Core. Not sure I follow you. Missing the parameter field after the core. So there's no parameter to this stuff because it's all gonna be stack based. Although this one doesn't look at the stack, so I just wonder if there's an align issue. Pointer not aligned at OXF. 10th core. I shouldn't need it. Oh no, I should, right? Yeah. Okay. 0. This is for alignment. We'll straighten it out more tomorrow if we get this. No. All right. Well, I guess this will give us somewhere to start. Pointer not aligned. Maybe that's this dot. We haven't used that before, so that could be it. Nope. Okay. Now we're back to that. All right. Well, we'll figure it out tomorrow. Let's see. This is Wednesday. Yes. So tomorrow, 2 to 4:30 Eastern, 7 to 9:30 p.m. UTC. We got print going and we got our assert working much nicer, and we're starting to work on our core thing. I'm happy. We'll have some core stuff done tomorrow and go from there. All right. Thanks for joining. Thanks for the help, Mudshark, and see you another time.